Physics students, Mr. Resentis here again. I'm on page 173, chapter 5, conservation of energy. Now, by this time you should have studied kinetic energy and potential energy and understand those equations, because now what we're going to do is put those together. And when we put them together, we find that mechanical energy equals the potential energy plus the kinetic energy, or the sum of the kinetic and the potential energies. Now, kinetic energy plus the potential energy due to gravity and the potential energy of the spring, these energies are constant. What that means is they're conserved. They are not created nor destroyed, they're only transferred. Within a mechanical system, ignoring friction, of course. So the energy, the total energy of a mechanical system is going to be kinetic energy plus potential energy due to gravity. Now, in none of our equations will we have potential energy due to gravity and potential energy due to a spring, but it's possible. We could do that. But we're going to have, you'll have equations where it's kinetic energy plus potential energy. And you should remember these equations because they're going to come up. They're going to come up again and again. So the total, energy total, for example, will include the equation 1/2 mass times velocity squared plus potential energy due to gravity, which is mass times gravity times height. So you'll have to put both of those together. And also what you'll have to do is you'll have to remember that the potential energy, or the total energy, and potential energy, of course, the total energy in system 1 equals the energy total in system 2, before and after. So, because energy can only be transferred. If I were to lift a heavy load onto a cliff with a height, that would be work, because it's force times distance to get it up there. So that work is equal to the potential energy of it sitting there, which is equal to the amount of energy that's transferred to kinetic energy as it falls back down. Right? So we know, for example, that velocity is in kinetic energy, so we're going to have to find velocity whenever it falls back down, just like we did with the kinematic equations. So if we know potential energy, we know kinetic energy, we know work. Right? Let's give a try to example 1. A jet with a mass of 2.0 times 10 to the 4 kilogram coasts through the sky at an altitude of 1 times 10 to the 4th meter with a velocity of 250 meters per second. Find the total energy. Well, we know that energy total equals potential energy, and that's potential energy due to gravity, of course, plus the kinetic energy. And so those equations, as I just wrote them, are here. So if we know the mass times gravity times height plus 1/2 mass times velocity squared. So if we know that 2.0 times 10 to the 4th kilogram is our mass, times the acceleration due to gravity, 9.81 meters per second squared, times the height, we've been given the height as 1.0 times 10 to the 4th meters, plus 2.0 times 10 to the 4th kilograms times, that's 1/2 of course, my apologies, 250 meters per second, and that's squared. Right? So if you add both of those together, the energy total equals 2.59 times 10 to the 9th joules. A whole lot of energy, because we have a whole lot of mass and we have a whole lot of altitude. Alright? So all we did was we just added those up together, total energy. Now, if that same jet dived to an altitude of 2.0 times 10 to the 3rd, that's 10 to the 3rd. I should have superscripted that, my apologies. Find the new velocity of the jet. Well, energy total equals potential energy due to gravity plus kinetic energy. Again, 1/2 mass times velocity squared. So if we just took 1/2 mass times velocity squared equals energy total, which we already found out. We already found out energy total. Gravity. Okay, so what we want to do is we want to solve for velocity. So in this, in order to solve for velocity, we're going to have to get velocity by itself, which means that we're going to have to multiply both sides by 2, and then take the square root, and then divide by mass, so that we can get mass over here on this side, and we're going to have to take the square root, and then we have to multiply this side by 2, aren't we? So that's going to be equal, velocity equals 2 times energy total minus the gravity over mass, and total energy doesn't change. We already have that. So velocity equals 2 times 2.59 times 10 to the 9th joules minus 2.0 times 10 to the 4th kilograms, and then the acceleration due to gravity times the 10 to the 3rd meters, that's the height, divided by 2.0 times 10 to the 4th kilogram, which is our mass, and don't forget to take the square root. Don't forget to take square root. If I plug that in, I think, pretty sure velocity equals 469 meters per second. Alright. Another look. Alright. Now here, this is an example that's actually that I got from your book. This is practice E on page 177. A bird with a speed of 18 meters per second drops a 2 kilogram fish at the altitude of 5.4 meters. What's the speed of the fish when it hits the water? So you'll follow along with me on page 177. And well, we know velocity. We know velocity equals 18 meters per second. That's going to be handy. We know mass equals 2.0 kilograms, and we know the height equals 5.4 meters. Alright, well that's handy. Now, kinetic energy equals potential energy, and the kinetic energy of system 1 plus the potential energy, and these of course are of gravity, no springs here, equals the kinetic energy of system 2 plus the potential energy of system 2. and we know that the kinetic energy is 1/2 mass times velocity squared. Potential energy equals mass times gravity times height, right? All right, so if we start plugging 1/2 2.0 kilograms times 18 meters per second squared. Now square that plus 2.0 kilograms plus the 9.81 meters per second squared plus the height 5.4 meters. Alright, now that equals the energy energy total. And so if you put this into your equation, that's energy total for system 1. So that's energy total for system 1, which is 429.9 joules. That's the energy system for system 1. So now what we want to know is the velocity. So we could set that to 1/2 2.0 kilograms times the velocity 2. That's what we want. Velocity 2 squared plus 2 times 9.81 times 0, because we've hit the ground. We've hit the water. There's no speed when it hits the water, so it's 0. So this all goes to 0 basically, and so what we're going to have is energy total equals the square root of 2 times 429.9 joules divided by 2, because what we want is we get this v by itself. This all drops off because we have no velocity. We get this v by itself. In order to get this v by itself, just as before, we're going to have to multiply this by 2, and then to get rid of the half, we multiply it by 2, and then take the square root, and then divide by the mass. And so we divided by the mass. So this is 2 kilograms, and we multiplied by 2, so we can get rid of that half. And this number came from the energy of system 1. And if you plug this in, energy total, velocity of I'm getting ahead of myself. Velocity equals the velocity equals it's 20. Hold on, it's 20. I always want to make double sure. 20.7 meters per second.